Hello everyone, my name is Darla Saunders, and on behalf of the Atlantic Salmon Conservation Foundation and the Canadian Rivers Institute, I would like to welcome you to today's webinar. This series is made possible in part thanks to the contributions of the Government of Canada. For today's webinar, we're very pleased to be hosting Marie Clément. Marie is an aquatic ecologist at the Marine Institute Center for Fisheries Ecosystems Research of Memorial University and is based at the Labrador Institute in Happy Valley Goose Bay in Labrador. She received her bachelor's degree from the University of Moncton, her master's degree from UNB, and her PhD from the University of Guelph. Since 2012, Marie has developed an aquatic research program to address knowledge gaps with respect to fish populations in Labrador. The overall objectives of this research program are to generate scientific information to assist in conservation, fisheries management, and food security in Labrador, promote sustainable economic development, and develop mitigation measures applicable to Labrador, create training opportunities for highly qualified personnel, promote community building capacity, and educate the public about aquatic science, fisheries management, and conservation. After the presentation, we'll be opening up the floor for a question and answer period. I will now turn the webinar over to Marie.
Well, thank you very much, Darla, and thank you everybody for attending this seminar. As Darla mentioned, I'm having a dual affiliation. So my main affiliation is the Marine Institute, based in St. John, but I'm based full-time at the Labrador Institute in Happy Valley Goose Bay. Today I will present the different projects that I and several other collaborators in the region about the salmon population in Lake Melville. Just to give you a brief overview of the presentation, I will first start by describing the Labrador Institute and what we are doing here. Then I present three main projects that are currently being conducted. The first one is to determine the genetic structure of Atlantic salmon in Lake Melville. Second one is to determine the river of origin and contaminant level, mainly mercury. And a third one is to develop a water temperature monitoring program, a network in the northern range of Atlantic salmon. Then I will keep going by suggesting a few other projects which could be a next step to move forward. And I will conclude by a discussion and question period. So the Labrador Institute is based in Happy Valley Goose Bay. We also having a research station based in Northwest River, which is about 50 kilometers from Happy Valley Goose Bay. And we're having a small office as well in Lad City. The general population of Labrador is reaching now about 30,000 people, and the population in Happy Valley Goose Bay is about 8,000. 40% of the population is having indigenous descendants, either Inuit, Nunavut, which their land claim is located on the north coast of Labrador, the Inuit Métis, Nunavut, which are located mainly on the south coast of Labrador, and the Innu Nation based near Northwest River in Shishishi, and also having a village in Natwashish on the coast of Labrador. This region is characterized by a subarctic climate and also characterized by remoteness, which also influence greatly fieldwork in the region. So most of the sites are not accessible by road, so we need either to take a large boat to cross Lake Melville. Actually, I will just go back a minute here. Lake Melville is here. It's a saline lake measuring about 140 kilometers into the interior of Labrador, and is influenced by tide. So to reach the sampling sites, we often need a larger boat and carry a smaller canoe to move into the river systems. Some of these sites are too difficult to access even by boat, so we need to use helicopter. And of course, during the winter, skidoo is definitely one of the best ways to navigate or to go to these sites. For a brief history of the Labrador Institute, it was first known as the Labrador Institute of Northern Studies and was established in 1979. The general mandate was to promote community development, establish a permanent link with the Memorial Campus in St. John, and stimulate and support major university projects, which at the beginning was mainly socioeconomic and research. The number of staff vary. It reached a peak in 1980 of about 15 to 18 staff and reached a low of 2 staff in the mean 1990. 1997, it had been renamed as the Labrador Institute. And during the strategic plan of Memorial University, it is now clearly identified that one of the priorities of the university is to increase its presence in Labrador and also increase the service that we can deliver to the population living in the region. And then during that time, the Labrador Institute research station have been opened. This is an old residential school that have been modified and renovated. You can see here we have an analytical laboratory, boardroom, accommodation, and of course, the equipment needed to conduct field work. In 2014 and 15, the Labrador Institute with Memorial University recruited 5 researchers or faculty members. We are all based here full-time at the Labrador Institute. So now we reach a number of 18 full-time employees, and during the summer, the number can reach 35, including summer student and research assistant. The main characteristic of this institute, and I believe its strength, is its multidisciplinary nature. We're having a researcher focusing on education, art and language, Aboriginal health, anthropology, archaeology, economic geography, and this is the first time that Labrador Institute is having natural resource scientists. So my colleague is working on earth science, soil science, and myself in aquatic ecology. So as mentioned earlier, the general objective is to generate scientific information to assist in conservation, food security, and the management of the subsystem and commercial fisheries, and increase MUN research capacity in Labrador. One very important point is to create training and job opportunity for research assistant, summer student, and grad student. Many migrant students are based during the school year at the main campus and taking their course, and then moving during the summer in Happy Valley Goose Bay to conduct their field season. On the project that I'm initiating are community-based, and eventually I would like to be community-driven research. So all my projects are oriented toward that goal. The first project I will be briefly describing is to determine the genetic structure of Atlantic salmon in Lake Melville. This project is being conducted by John Harn, postdoctoral fellow at Dalhousie, and Emma Sylvester, master student at Dal. I'm having several collaborators in Bradbury at DFO, Robert Vico at Dal, Paul Benson, and of course all the main players in Labrador, the Nunavut government, Innu Nation, the Labrador Hunting and Fishing Association, and definitely community members who play a very critical role, and is actually their support and collaboration is actually why we have been so successful in those projects. So the first objective is to determine if salmon in Lake Melville is genetically distinct and locally adapted. Determining as well if salmon fisheries in Lake Melville are exploiting a single or mixed stock. In this objective, there's 2 sub-objectives. The first one is to determine if Lake Melville is exploiting different stock native of Lake Melville, mainly also if it's exploiting more fish from a specific river compared to other rivers, and also determining if the fishery is exploiting fish that are spawning in other watersheds, So just entering the Lake Melville to feed and then exit and spawn in other area. And of course, we will be, with the genetic information, we will be able to determine the river of origin. The second objective, or the second project is conducted by Judith Savoy, master's student here at Memorial University. And we're conducting this project in collaboration with Saint-Louis, Jeviano, and the same collaborator that I earlier mentioned from Labrador. She's having different objectives. The first one is to determine the river of origin using autolyte microchemistry analysis. And of course, we will be able to compare both methods for inferring river of origin by using autolyte microchemistry analysis and also the genomic information. Second objective is to quantify heavy metal concentration in the subsistence fisheries with specific attention to mercury. I will touch a little bit further in detail the situation in Lake Melville, but there's a hydroelectric dam currently being constructed about 40 kilometers from Happy Valley Goose Bay. So methyl mercury is definitely heavy metal of concern in the region and in the food sources. She will be also conducting analytical method development comparing relatively new analytical method, the MPAES, with an accredited laboratory. I'll be presenting the methodology of those two projects, so the genetics and the autolyte microchemistry analysis and contaminant study together, as we use exactly the same database to generate those two projects. So all the salmon par were collected in 2013 and 14. In total, 21 rivers was visited, and par were successfully captured in 11 rivers. Actually, one of the characteristics of Labrador is its low water conductivity, so electrofishing is not efficient in those rivers. So most of these salmon par were collected by angling. So in total, 531 par were captured and sampled. Fin tissue and hard tissue were collected and preserved in ethanol for the genetic analysis, and the autolyte was removed to determine river of origin. Then in 2014 and 15, over 586 adults were sampled from the subsistence fisheries. And the Nunavut government was awarded a grant from the Atlantic Salmon Conservation Foundation. And with that funding, they were able to hire 2 summer students. One was based in Rigolet on the wharf and sampling the subsistence fishery. And another student was based here in Northwest River, again sampling the subsistence fishery. So when the fisher came back to the wharf, they were asked about the location of fishing, and fin tissue for genetic and contaminant analysis were collected, as well as the autolyte to infer river of origin of these salmon. So I'd just like to point out that my student did quite a good interview at APTN. So if you are interested to learn a little bit more about what they did and learn more about the project, I think it could be a good short news clip that provides a lot of information about the region and the importance of these projects. So to move on to the genetic project, we are conducting SNP genotyping, which is basically a novel analytical tool that allows us to define population structure and local adaptation with more confidence compared to microsatellite analysis. So during the fall of 2015, about half of the samples of juvenile salmon were sent to Norway for genotyping. And one characteristic is we were able to genotype a large amount of SNP array. Then the next step was to conduct statistical analysis to identify the optimal subset of SNP loci for salmon population assignment. So this step had been completed this summer. And now Emma and John are moving toward developing a laboratory assay for genotyping PAR at 443 SNP loci. So basically by doing so, they are identifying the main marker that can better characterize the different salmon population in Lake Melville. This is a graph that John sent me yesterday, and it's quite interesting. So you're having here on the y-axis assignment success in percentage, and you're having here all of the different rivers that were sampled. The site ID and the river full name is identified here for people who know the region. Basically, in most of the river, the assignment success was above 80%, except in two occasions, which is in Red Wine and Crooked River, which were often misassigned between those two rivers. And similar, Caroline Brook was often assigned to Traverse Pine River. When we combine those two rivers together, the success rate was above 90% of assignment. So these rivers were located in near vicinity. So Caroline River here and Traverse Pine River. And again, Red Wine River located here and Crooked River here. So this suggests that the population are genetically similar, or that they're having a high gene flow between those rivers. So during the fall and winter 2017, it is expected that all baseline PAR and adult fishery sample will have been genotyped, and we're expecting the results to answer if the salmon population of Lake Melville are genetically distinct and locally adapt by the end of the winter or early spring. Similarly, also for determining if the fisheries are exploiting a mixed stock. I will quickly go through the second project, which is being conducted by Judith. So basically here, I place a picture of an otolith, and an otolith is a bone in the ear of the fish. And the principle is very similar to a tree. You can, by conducting analysis under microscope, you can, for example, age the fish. You're having a growth season, winter bend, growth, winter bend, and go on. And the advantage of this structure is it can assimilate the water chemistry signature into its otolith. So we are able to reconstruct past history of the fish if we change habitat with different water chemistry. So basically the principle is that the river draining through landscape of different geological composition will show specific water chemistry, so having a distinct water signature. Fish assimilate the water chemistry of their natural river in the otolith, so the fish will assimilate the water signature and become the fish, and we would be able to quantify a fish signature. So by knowing the water signature and confirming that juvenile growing in those rivers show similar signature in their otolith, we will be able to then reassign an adult, and analyzing the different elemental concentration during the freshwater phase of that fish, we will be hopefully able to reassign to its natural river. So in total, Judith analyzed over 500 juvenile PAR and over 300 adult. She looked at those 8 different elements and conducted laser ablation at the laboratory of Memorial University in St. John. So for the PAR, she conducted spot analysis to have to determine the concentration of these 8 elements. And for the adult, she cut the otolith in half, polished it to the core, and conducted laser ablation in a transect from the core to the edge. Then she went back, determined the location of the freshwater phase, and then use a section of the freshwater phase to try to reassign it to signature and par from the different rivers. Her preliminary result for the salmon par. I won't get into much detail of all the stats, but basically here in this show, pay attention to group of similar cluster. So for example, here Traverse Pine is grouping together compared to I hope you're seeing the legend. I'm having the webinar window here, but hopefully you can see here, I think it's Clément, the star, and then this is Susan Brook. So we know now that several of these rivers are having a separate or distinct characteristic of these elements. And then when she conducted a cross-validation to reassign those parts to their group, she generally had a good success rate of reassignment, except in two rivers, Main Brook and Peters River. Now she superposed the adult on the juvenile cluster, and the assignment rate wasn't as high. Mainly you can see here that most of these adults were reassigned to Cape Caribou, Caroline Brook, Crooked River, Kinemu, which is not surprising. It's known as being a very productive river. Then very high reassignment to Susan and Traverse Pine. Madigan River is known to support an important salmon population. So now Judith needs to take in consideration as well the location of capture in the analysis to try to better understand how come there was such higher assignment for some of these this river and not in where we would have expected. For example, in Madigan River, there was only 2 fish that were provided near the mouth of that river. And as well, the next step is to compare the results of river of origin with the genetic. So hopefully by the 2 methods, we will be able to better understand from which rivers the fish that are being exploited in the subsistence fisheries are coming from. Moving toward the second part of Judith project is to quantify contaminants, particularly mercury. As I mentioned earlier, there's a hydraulic development occurring presently in the Lower Churchill River, which is about 40 kilometers upstream in the Lower Churchill. And the Labrador Institute has recently acquired MPAES, which is a new analytical tool that is very advantageous in remote area, as it's less expensive and requiring less sophisticated laboratory to be functional. So it's a good, it's definitely a very practical analytical tool that could be used to increase research capacity here in Labrador. However, this technology have not yet been used to quantify concentration of different elements in fish tissue, so method development was required. I will just briefly present some of her results. Here she tested the accuracy of the MPAES against certified reference material. So she had 5 replicates, and the certified value of this reference material was 0.382. So, and this is the concentration of mercury that she recorded using MPAES. You can see here that the recovery, which is basically an expression of accuracy in percentage, was quite high, except for one sample, which the value was underestimated. She also conducted analysis using MPAES, and forgot to mention that all of these analyses were conducted at l'Université du Québec à Rimouski. And then she compared her results to result obtained from an accredited laboratory located in Lake Henry University. Again, the bias was low, very similar. Most of the time it was overestimated, for example, 7%, here 19%. Some occasion it was underestimated with an overall recovery of 106%. So I thought we need further method development. This new technology seemed very efficient to quantify mercury in salmon muscle tissue. Then moving to the last projects is to develop a water temperature monitoring network in the northern range of Atlantic salmon. I'm sure a lot of you is aware of the rift dump that was developed by INRST and in collaboration with several partners in the Maritime region and Quebec region. So basically, we are extending that network to Quebec Lower North Shore, Newfoundland and Labrador, Nunavik, and as well we want to extend to all the way to Nunavut to be able to monitor water temperature in rivers that could potentially be colonized with climate change. Showing here a picture of Liana Rice, my research assistant, and Dean McNeil, conservation officer from NG, who have been assisting Liana with another conservation officer to reach those remote areas in Lake Melville. This is a preliminary map over the station that have been monitored during this summer. So we're having several stations in the Quebec Lower North Shore, in the Nunavut region, in Nunatsiavut, and also in Upper Lake Melville. Out of the thermographs were mainly installed by our collaborator, mainly the conservation officer from NG and as well Nunatsiavut, or fishers or owner of a fishing camp. So again, this project has been successful based on all of the effort and collaboration from diverse groups. So the next step is to, when the data will be analyzed and data interpret, the next step will be to conduct a tracking study to confirm river of origin infer using genomic and alternative microchemistry analysis, and as well develop a community-driven observer network that could be combined with the water temperature network to identify real-time shift in salmon distribution in relation to climate change. In conclusion, I'd like to acknowledge Liana Rice and Josh Adam, which was Liana was a summer student in 2014, and now she's my research assistant during this year. Definitely acknowledgement to the Nunavut government, Nunavut Community Council, Innu First Nation, local fishers, Labrador Hunting and Fishing Association, and provincial and federal government. Out of these projects that are presented were funded by the Atlantic Salmon Conservation Foundation, either allocated to NG or myself, so they play a critical role in supporting this project and make it realizable. And all of the different other funding sources are listed below. So I will open the period of question or discussion.
Thank you very much, Marie. That was an excellent presentation and a really interesting overview of the project and how things are moving along. So as Marie said, we'll now open the question and answer period. Questions can be asked in English or in French. Vous pouvez poser des questions en français. To ask a question, use your webinar control panel, which is the little gray box you should be seeing in the upper right-hand portion of your screen. So if you're using the audio of your computer and you have a headset, you can figuratively raise your hand, which is the yellow hand icon with the green arrow. We'll unmute you and you can ask your question directly. Or you also have the option of typing in your question on the control panel and we can then read it aloud for you. So we'll give folks a few minutes to compose their questions. So Marie, I can just think of one quick question while we're waiting folks to enter them in. I was quite impressed by the geographic distribution of temperature monitoring that's going on right now. And I'm wondering, were you able to capitalize on any temperature monitoring that was already existing, or are those all new, new monitoring locations?
Out of the, I can go back. Out of these, our new location, there was a few sites, for example, 7 thermographs that are being monitored or installed by DFO in 7 rivers along the shore of Labrador. So these ones have not been included, but we by the end of the field season, all of this information will be placed together. DFO is already contributing to the RIV-10 network in Quebec. So that will be completed for those rivers. So all of these blue dots, except these ones, they are located in the Tongaat National Park. So this will be provided to us by the Tongaat Park. So they have been monitoring that for several years now. And actually we're having here Nunavik Research Station is planning to install thermograph in 13 rivers in Nunavik. But I haven't yet installed it, as I'm not sure if they were successful in deploying the thermographs. So this is actually conservative. And the first year, what we're doing is actually the first year we are monitoring a lot of rivers, and the objective is to make it manageable over the long term. So with time, we will select index rivers, so the number will possibly or most likely be reduced. But for the first year, we wanted to extend it as much as possible to get a good feel of the patterns.
Excellent. And are the thermographs that are being deployed, are they remotely accessible? Like, I'm wondering if it's possible to access the data without then revisiting the site, or if you have to do a physical download of them.
Yeah, and we need to retrieve the thermograph and download it. And for the first year, I thought the Tongaat Park is installing their thermograph permanently, so they are monitoring winter as well. For this year, we're only monitoring summer water temperature. We will need to have fixed stations, for example, boating the anchor to a rock or bedrock. So we won't lose the thermograph during snowmelt.
Yes.
So they installed it early during the spring or early summer, and then they will go back to retrieve them in October, which is one of the difficulties, the remoteness of those sites. So it did require quite a bit of effort from all of our collaborators to install of those thermographs.
Yes, I imagine it would. All right, well, we don't seem to have received any other questions, so I will invite folks, if they do have questions for Marie that come up afterwards, to please feel free to send them along. If you send them to email them to me, I'll be happy to pass them along to her after the presentation. So a big thank you to Marie for talking about her research projects. A really, really interesting presentation. The next
thank you very much, and thank you for giving me this opportunity to present the different projects and sharing the results that are starting to become available. So thank you very much.
Thank you. Well, we really appreciate it. So the next presentation in our series is going to be on October 19th. Eric Martin of the Nature Conservancy in the U.S. is going to be speaking about decision support tools for prioritizing barriers to aquatic connectivity. On October 26th, Steve Dugdale of the University of Birmingham in the UK will be giving a presentation in French entitled La télédaction des milieux fluviaux. A big thank you to everyone today for participating, and of course the biggest thank you to Marie for making the presentation, and we hope you will all join us again very soon.
Thank you. Bye-bye.